and get to work here. So the last thing in this particular unit focuses on applications associated with an equation, i.e. word problems. So it's not like you go in the store, you're looking in the produce aisle, and you're going to see an equation just sitting there. All the problems that you solve out over the course of your life have some kind of mathematical manipulation that you're going to have to do. That doesn't necessarily mean you're going to be setting up and solving an equation, but it does mean that you're going to have to think out how are you going to solve out a problem. That definitely goes for anyone who is going to run a company, own a business, work in medicine, so on and so forth. Because there's a domino effect. Your actions affect other people, affect other things, affect other people's money. Easiest way to get someone mad at you, mess up somebody else's money. It's the easiest way to get sued and deal with other stuff. So, when it comes to solving an applied problem, that's all a word problem is. It's an applied problem. First step is to read the problem. And in some cases, that means reading it several times. Some of you may have to read a word problem 2, 3, maybe 4 times to understand what they're giving you and understand what you need to find. In my graduate school classes, I found myself reading a problem 3, 4, 5 times just to make sure I understand what they're asking. Again, it's the mantra of you have time to do it right or you have time to do it over. Either make time to do it right or make time to do it over. So, read the problem, assign a variable to represent what you're missing. Whatever you're missing, give it a variable. Most of the time it's X, but you can use whatever letter you want. Write the equation, solve the equation, of course give your answer, and then check to make sure it makes sense. Check your answer and make sure it's something that's relatively valid. So again, some of you will go through this process faster than others. But key thing here is setting up and solving an equation. So the first 2 steps set up the rest of the problem. So there's blank space here just to remind you the steps for solving an equation. So remember, your first step is to distribute. Second step, combine like terms. Third step, move variables to one side. Left side, right side doesn't really make a difference. Step 4, eliminate adding or subtracting. And then step 5, eliminate multiplying or dividing. So what you need to do depends on the problem that's set up. There is no cookie cutter, one size fits all. Another thing to keep in mind, over the course of the next 2 days, we're going to do several word problems. These are not the only word problems that exist. So when you're doing your homework, or when you get your test, or when you take your final, if you have to, or when you take your placement test, whatever you need to do over the course of your life, know that this is not the end-all be-all. You're going to have other problems that pop up and that exist. So it's not a cookie cutter. What you're learning is, how do I process the information to create an equation so that I can solve a problem. So we're doing several examples, but these are not the only examples that exist. If I were to give you every example that possibly exists, we would be here until the end of time. Out of time for all that. So know that the examples that we're doing, these are not all the examples that exist. So with that, let us begin with example number 1. So first off, we give you a moment to read the problem so that you can get in the context. So take a moment to read the problem. So let's go ahead and get at this problem. Profit of a company is found by taking its revenues, the money it makes, minus its cost, the money it's spent. If your shoe company spent $3,920 this week and you earned a profit of $2,180, how much did you make in revenue? So the first sentence tells you the general setup for profit. So profit equals revenues minus costs. How much money you made minus how much you had to spend. You spent $39.20, you earned a profit of $21.80. How much did you make in revenue? So step 1, read the problem. We're asked to find revenue. Step 2, assign a variable. Pick whatever letter your heart desires. So in this case, we're letting X represent the revenue. You can let it use whatever letter you want. So your first step, read the problem. Second step, figure out what's missing so that you can assign a variable to it. Step 3 is the critical step. That's setting up the equation. You can't solve the equation if you don't have one set up. So since profit equals the revenue minus the cost, it told you that the profit was $21.80. The revenue, you don't know. And you spent $39.20. So your cost was $39.20. There's your equation. There's the equation that you are going to have to solve. Any questions so far? So once you have the equation set up, now we solve it. Now we got something that we can solve. So if I'm going to solve that equation, what do we do to both sides? Okay, how do we do that? Add those on both sides. So X, which is your revenue, is those two numbers added up. So how much does this shoe company make? So $6,100. So 6,100 in revenue. $6,100 in revenue. Uh-huh. So R means revenue, C means cost. Revenue is how much you made, cost is how much you spent. So to recap for that problem, number one, you read the problem. Read the problem first. Read it multiple times if you need to. Step two, figure out what's missing, what you need to find, give that the variable. Step three, set up the equation. Step four, solve the equation. So again, word problems are as hard as you make them. But they're definitely going to be hard if you don't read it. They're definitely going to be hard if you don't read it. Questions, first example. Not saying you're hearing me, so let's go on to second example. So second example, we're going to deal with another problem involving profit. So here's your problem. This time I decided to include Derek in my shenanigans. Go ahead and read the problem. Go ahead and read the problem. All right, so this type of problem you may have also worked with in economics. So if you take in economics, which I'm assuming all of you have, whether it be during the summer or you took it first semester or whenever you took it, because you're taking it now, you deal with something called breaking even. So breaking even is when your revenue equals the cost. Your revenues equal the cost. How much money you make equals how much money you spend. So Derek owns a car detail company. He charges $65 per car. So for every car he details, he's charging $65. Derek, no offense, he didn't play, bro. The average detail is about $90. So I'll come to you because you're charging 65, but you're shortchanging yourself. So $65 per car. For car detailing, he has to spend $48 per car for supplies, plus $272 fixed costs for labor. How many cars does he need to service in a day to break even? Again, first step, read the problem. We're being asked to find the number of cars being serviced, number of cars he has to work on that day in order to break even. So that means X is going to be the number of cars. You don't want to use X? Okay. Use another letter. Use C. Use B. I don't care what letter you use, just pick one. All right, so any questions so far? Any words, anything that's causing you difficulty at this point? Remember, you should always be asking yourself, if I can't figure this out, if I couldn't figure this out by myself, then where would I have gotten stuck? If I can't figure it out by myself, where would I have gotten stuck? That own self-advocacy that you have to take now. All right, so let's set up the equation. So, Derek's car company charges $65 per car. Do I know how many cars that he worked on? No. So that's 65 times the number of cars that he's going to work on. So $65 per car is 65x. For car detailing, he has to spend $48 per car. So $48 per car, so that's 48 times X, times the number of cars, plus $272 in fixed costs. So I'm pretty sure Derek's not working by himself. He probably has a couple people that he hired to help him. Or he has a space that he's using that he's got to pay the rent for. That's $272. How many cars does he need to service to break even? Break even means revenue equals cost. How much is he making? $65 per car. There's his revenue. 48x plus 272. Here's his cost. So to break even, 65x equals 48x plus 272. Any questions before we start solving? Any questions before we begin solving? So if something is costing you something, what are you doing with your money? So the fact that he's spending $48 per car, that's a cost. That's costing me money. $272 is fixed costs. So that's costing me money. If you're charging $65 per car, that means that's money that you're going to make. So, no problem. Like I said, ladies and gentlemen, for some of you, you may have to read a problem 2, 3, 4 times to understand what everything means and where to place everything. So you might have to do that 2, 3, 4 times. Does that make you bad at it? No. That just means you're doing what you need to do so you can get it right. Again, there's 2 things in this world. You have time to do it right, or you have time to do it over. But now we're going to solve it. So now we're going to solve the equation. Jordan Johnson, I love you, but don't say anything in this problem since you solved all the first. How do I solve this equation? So, what's left over? X equals 16, so he's going to work on 16 cars. You're going to work on 16 cars that day if you want to break even. $16 cars a day in order to break even. So hopefully you got a good crew. And hopefully you're not having to do it all by yourself. So, questions on example number 2? Yeah, word problems aren't difficult. It just requires you to read. Requires you to read, requires you to put in a little bit of work. All right. So, third example. Take a little bit of a step back here and let you try to, I'll let you read it and start trying to set it up. So, there's your problem. So this time, let me give you a couple of minutes to start trying to solve it. Pause my recording and start looking at this problem together. A box contains a combined total of 68 pens and pencils. If the box contains 16 more pens than pencils, how many of each are in the box? How many of each are in the box? So we need to know how many pens, how many pencils. How many pens and how many pencils? So we read the problem. We know what we have to get. So, what are we going to use for variables? So what did you use to set it up? Okay, so he's going to use 2 different variables, which is okay. It's okay to use 2 different variables, but we're going to try to keep this to 1 variable. So we're going to keep this to 1 variable. So we're going to keep the x. What did they tell us in that problem about the number of pens. What did they tell us in this problem about the number of pens? 16 more. So if you have X pencils, that means you have X plus 16 pens. If you take the number of pencils and add 16 to it, that's how many pens are in that box. So instead of using two different letters, we can keep it to one letter. When we use two different letters, that's called solving a system of equations, which all of you have done before, but we're not there yet. Right now, we're going to try to keep it to one variable. So, any questions so far? If there's something that just doesn't quite click, you gotta say something. Don't let the time you want to say something be when you have a test in front of you. So we know what's going to represent what. Pencils are X, pens are going to be X plus 16. So now we can set up our equation. So remember, pencils are X, the pens is X plus 16. So we need an equation. What would be the equation? You're good so far. There you go. Same way to stay through it. That first sentence told you everything you needed to know. A combined total of 68 pens and pencils. So that means the number of pencils plus the number of pens has to equal 68. Take those two, add them together, that equals 68. So there's your equation. There's your equation. Any questions before we continue? See, Nia came off mute, so she must be ready to go. That's fine. I wasn't trying to run you off. Go ahead. Go ahead. It's your world. Let's go. All right, so X equals 26. So since the pencils were X, that means we have 26 pencils. So how many pens do we have? So that means 26 plus 16, plus 16 would be 42. You answered their question. It's not hard, just a little work. And I know some of you are probably thinking, it seems so easy when we do it in class. I do it by myself. It's hard. It don't have to be. Uh-huh. That's right. So the directions said how many of each were in the box. So if you just solved for X, that means you just found out how many pencils there were. They want to know how many of each there were. So now you take the 26 and plug it in, do that quick adding, and then you get the number of pens. No problem. Now, to go back to what Steve had said at the very beginning. So when he said that X was equal to the pencils and Z was equal to the pens, he wasn't wrong. He didn't do anything wrong. We're just not using two variables. If we were to solve this problem using two variables, then you would need two equations. If you're going to have two variables, then you need two equations. So the problem would have been X plus Z equals 68, and Z equals X plus 16. If you're going to use two letters, you're going to have two equations. We will eventually get here, but we don't need it yet. We will get there, we don't need it yet. All right, so this is a good place to take a short break. Let's take your last paycheck was $780, which you have to place into two bank accounts, a savings account and a spending account. You must deposit $14 in the savings account for every $1 going into the spending account. How much money must go in each account? So, of course, you all are much younger than I am. Take this time now to figure out a good practice of spending versus saving your money. You will be glad that you did when you get older. But if you build that habit now, you'll keep that habit going as you get older. So in this case, your last paycheck was $780. The thing is, you must put $14 in the savings for every $1 that goes in the spending account. So, we're missing two things. How much is going into spending? How much is going into savings? So let's set up some variables. Do we know how much total is going into spending account? So, do we know how much is going in there? Of course we don't. No. We don't know how much we're going to spend. So that's X. We don't know how much we're going to spend. We do know that for every $1 that goes here, 14 has to go into savings. So let's think about this numerically. If I put $1, if I spend $1, I have to save 14. If I spend $2, how much do I have to save? 28. If I gotta spend $3, How much do I have to save? Think of it as your own money. It's $3. You're going to spend $3. How much do you have to save? Two. So every time I go up $1, I have to save 14. Every time you go up $1, you got to save 14. So that means your savings account is going to be 14 times the amount you're going to spend. $14 times the amount that you're going to spend. Let's think about why that makes sense. 1 times 14, 1 times 14 gives you 14. 2 times 14 gives you 28. 3 times 14 gives you 42. Now, the reason why I explained it that way is because some people will set this up as x plus 14. Here's why that doesn't work. If you take 1 and add 14, it's 15. You take 2 and add 14, that's 16. You take 3 and add 14, that's 17. So it doesn't match up. You need something that's going to match up. Any questions before we continue? Then always ask yourself, is this a problem that I can reasonably solve? Set up the equation, solve the equation by myself. So if I see this next Friday, will I be able to solve it? If I see it next Friday, will I be able to solve it? So now we know what's going where. So we know that spending is X, saving is 14X. So your whole paycheck is 70. So what's our equation? What equation could we set up? Perfect. How much you're going to save plus how much you're going to spend equals your total paycheck. Save plus spend equals your total. So we've got our equation. Let's go ahead and solve it out. Now what do we do? Let's see. So X equals $52. So that means you are going to spend $52. So that means how much are you going to save? $128. 15 times 52. So that's how you're going to divide up your paycheck. Spend 52, save 728. I wish it was that easy. I wish for myself it was that easy. That I only had $52 that I had to spend on bills. So, any questions on that example? I think that's, let's see, how many examples? Pause this for a second.